So we recently built a custom RAG workflow process with Twitter data, which basically helps users to retrieve tweets based on the user requirements, like a user input. Let's say a user wants to see tweets that are talking about AI, that are talking about how to optimize Google ad spend. Basically, the tweets that are talking about specific topic and context, and automatically the AI, aka the RAG workflow, is able to retrieve the similar tweets and present to the user. This helps users to come up with better content ideas, better content pieces, so they're able to level up their authority levels on their personal brand. Now, this is not strict, and basically this is not strictly just for tweets. This can be done basically with any documents, PDFs, knowledge bases that you have inside of your company that you can utilize RAG workflow to literally automate this part of the process in your business, right? And gain an edge with AI and this new technology that has come around. So in this video, I'm going to showcase you how to do that, how to build a custom RAG AI workflow process agent, and how you can basically implement it inside of your company as well. Now, let me showcase you before I go into it. Let me showcase you a quick demo of how this works. Very simply. Let me just go here inside of the code. And also I'm going to showcase you and explain to you how and why is RAG important, and why do you even need RAG when building custom AI solutions and agents. Before now, as it loads, we are building this for one of our particular clients, which RAG is just one minor, aka one smaller part of this big AI ecosystem, big AI solution that we're currently building it for them. And even though it's like a smaller part, it's very important. It's like one of the crucial pieces in this just AI part of the whole the solution that we're building it for them. So let's say I'm a user. I want to see the tweets that are talking about AI, very simply, and I can be just like, yeah, give me tweets about AI, and basically what will happen, the AI, aka the RAG workflow, will go inside of our vector database, retrieve specific tweets that are talking about AI, meaning it will look up for similar tweets and will provide us with those tweets back. Now, here, as you can see here in the terminal, the RAG agent is activated. It's already generated the response, and now we're just waiting for the final output. As you can see here, if we look at the single tweets, we're able to see, okay, here he's talking about AI, about AI, about AI, and about AI, right? Everything is about AI. Now I can be very granular. I'm also going to showcase you how you can utilize query retrieval process, like a query retrieval function, which basically helps you to filter out based on the metadata requirements. Literally, I can be like, okay, just give me the tweets about AI from our clients, which is basically one of our metadata fields. Or I can be like, just give me the tweets about how to optimize Google ad spend from the niche of ad creatives, right? And it will do that for me, right? So this is just a quick demo how you can go about, just a quick demo of showcasing you one of the solutions that we built. So how to build the RAG workflow, RAG chain, however you want to call it, step by step. Now I'm going to explain the simplest terms of how to go about this. First of all, the first steps, you have the source, which is basically your unstructured data. You have your text, your images, your voices, whatever it is. In our case, this is the text tweet data. In your case, it could be, let's say, PDFs, knowledge-based documents that you have laid around your company. The second step is the transforming. Let's say here in our case we have tweets and text, and they don't need a lot of transformation. But let's say if you're using a long format PDF files, very long, complex documents, you will need to chunk it, which is basically the process of taking those long format documents and basically chunking it into smaller ones. Imagine having like a PDF file long way over 200 of pages. You're gonna now chunk it in 200 of chunks, right? Basically, they're gonna become much more smaller and they're gonna be very easier to ingest and embed inside of your vector database. In our case, because we're dealing with tweets text data, they're already pretty much chunked because majority of tweets have like between 50 to 300, 500 characters. But what we've done here, we just made them consistent, meaning we removed specific empty lines, we removed specific grammar mistakes, and so on and so forth, because that will be very important in our semantic, aka similarity search, when we do the retrieval process. Then the third step is the embedding process. Now, this is the more a little bit, you can call this complicated. I'll also link down below a link which describes this process very in depth and in the simplest terms, so you're able to understand it. In short lines, embedding process, imagine you take those unstructured data, let's say text, and we convert it into the long list of numbers like this. Let's say we have a word hello, we will convert it into the long list of numbers, let's say 1, 2, 4, 6, and then we will take those numbers and we will format it in terms of like in a vector format, which is basically this, right? And this is a vector, what we call here, basically in short lines, this. And in our case here that I'm showcasing you in this example, this is a 4-dimensional vector, which is because we have 4 dimensions, okay, 4 numbers. And what does that mean? That means that we are describing this word in 4 different ways. We have like 4 descriptions, let's say hello, greeting, word, whatever it is, right? In our case, because we are using Pinecone, a cloud-based vector database, and also using OpenAI embedding model, we have the ability to describe use dimensions of over 1.5k, which is 1563, right? Meaning that we are describing this word in so many different ways that we are able to produce and retrieve the most relevant documents, right? The longer the dimensions you have, basically the longer the descriptions, the more in more detailed you're describing that specific information, which basically means, let's say this hello, this is the 4-dimensional vector. In our case, this could be a long list of numbers, right? Because we are describing this word in so many different ways, right? In different ways, patterns and characteristics. Then once we're done, we embedded that those vectors, which is basically this, are stored inside of the vector database. In our case, we are using Pinecone, cloud-based vector database, but you could also utilize like Chroma is big, Face, which is the meta one, and so on and so forth. But in short lines, we store it inside of the vector database, which basically looks something like this. Let's say because we have we converted the unstructured data into a long list of numbers, all of the similar searches are going to be very, very close to each other. And when a user inputs a specific request, the AI will be able to automatically see, okay, this is very similar. We are looking for this type of information. All of these informations are very similar. Let's retrieve it, and we will retrieve it, which is basically the retrieval documents. We will retrieve the documents, and then we will format the final output, and the user will get the output that they desire. Similar like we showcased you at the start of the video, which I basically asked, what are the give me the tweets about AI, and the AI gave me the tweets that are talking about AI. Not just using the keyword AI, not that, but they're like strictly talking about words. The topic about the tweet is regarding AI, right? Now, I'm also going to showcase you later down in the code how one important thing that I potentially missed is basically once we embed and vectorize this inside of the vector database, we are also adding metadata fields, which I'm going to showcase you now in a second. So basically, these are the metadata fields. Basically, these are fields that are coming alongside the text that we vector or that we embedded, which helps us with searching, filtering specific piece of information, right? It helps us very, very simply to retrieve even more relevant piece of information, because like I could be asking, let's say in the example that I give you above, I could be like asking, okay, give me the tweets talking about AI that are just coming from our clients, or that are just in the niche personal branding, and it will give me that, right? And if we look here also inside the vector, you're able to see the text, the URL, the username, and so on and so on, so on, right? Basically the added piece of information. And in regards to the embedding and vectorization, as you can see here are the values, right? Way over 1,563 values, and here's the score. Basically the score 1, score was 0.6, and the higher the score, the more similar it is, right? And basically, let me just go back now here. And this is basically the short lines, the whole RAG workflow. More important thing to understand here that this is not the agentic RAG system. Agentic RAG system difference is that the agent decides what tools to use, right? In our case, it's a step-by-step approach, meaning basically the user inputs the query then gets passed around to the LLM to search inside of the vector database for similar information, which is basically called similarity search, semantic search. Then we retrieve the documents, and then we format the final output. Basically, it's like a step-by-step assembly line type of workflow, right? It's not an agentic system yet, but down the line I will also record a video how you can turn this into agentic systems. That's beneficial if you're utilizing, and if you want to have an agent that utilizes multiple different tools. Basically, the agent will decide, okay, what needs to be done, and potentially you might have connected specific type of knowledge base next to it or anything else, right? So now let's go and showcase you how we done this inside of the code. So I'm going to showcase you how to do this step by step. The first phase that I'm going to showcase you is the embedding part, meaning how to get your data, okay, from this step all the way to the vector database, okay, in our case embedding the text of the tweets. Then I'm going to go and showcase you the retrieval document part and how to retrieve those documents and format it in the correct final output. So let's go into it. So here is our code. Let me showcase it here. Now the code, let me go here in the embedding part. Now, as I said at the start, our RAG solution, okay, workflow is a smaller piece of the bigger solution that we're building, which I'm not going to go into it at the moment. But in short lines, pretty much stays the same. But how we are getting the text, okay, our source documents are from our data warehouse, which are stored there, and we're also getting them from the direct Twitter API. Now, regarding put that aside, the first step to do is to import all the correct libraries. Then, in our case, we initialize where our documents are. Basically, in our case, the data warehouse, which is the Google Cloud credentials we need to do. We also set our API keys, which is the Pinecone API key, because we are utilizing the vector database cloud vector database called Pinecone. We initialize also and set our OpenAI API keys. If you're utilizing any other LLM, just use them. And view also the environment from the vector database. Important thing to mention here, we're utilizing LangChain as our agentic framework. Then we load them. Then we initialize the Pinecone, which basically you can get this on once you sign up for their software. It's going to send this. I already explained the index and the vector dimensions at the start of the videos. Here is the retrieval, not retrieval part, but here is the processing part. Basically, we're getting the documents, we're getting the text, the text of the tweets from the data warehouse with this query. We clean them. Basically, we remove all of the useless parts that would potentially hinder the semantic search, okay, the similarity search, right? We remove the URLs, we remove the mentions, we normalize the white space, right? Then the third step is we generate the embeddings, right? In our case, we utilize also some other parallel function, which makes all this process much more faster because we have way over 60,000 tweets stored inside of the data warehouse. For now it's way more. But generate embeddings, right? Basically, in short lines, you can get this one also on their Pinecone documentation if you decide to check it out. We also utilize the embedding LLM that we're utilizing is from the OpenAI, which is basically the text embedding free small, right? That has been working for us probably the best. And yeah, as I said, we are utilizing also some parallel functions to make everything much more faster. Then we also prepare the metadata alongside the embedding the text of the tweets, actually vectorizing that. We also include the metadata fields, things like tweet ID, text, username, real niche, tweet posted, client URL, and so on and so forth, right? We make sure also we are putting that in the correct format based on the solution that we're building it. Then we upload everything inside of the Pinecone, right? We basically, because we are utilizing the upload function, we are also making sure that there is no duplicates inside of the Pinecone, okay, vector database. And because we're utilizing the upload function, that means that the existing, it checks based on the tweet ID, the metadata field, and also the text, to see if there is any existing tweets, vectors that are already vectorized inside of the Pinecone. If there are, they just get overwritten, right? So that ensures that there is no duplicates inside of there. We also have it, as you can see here, we upload it in the smaller batches, so we are able to navigate it here inside of the log panel, the terminal. And that's basically pretty much it, right? This is the whole process. As you can see here, we have some other processes here, like extracting the tweet IDs to making sure there is no duplicates and so on and so forth, right? But pretty much everything is here done in that specific specific steps. Now the last function is making sure that everything in the workflow. As you can see here, we have the def store all the tweets, and all of the steps that I just described above are here in the exact order like they should be, right? And also here at the end we have it the log vector update, which basically logs all the tweets that are already inside of the pinecone, just so we know, right? So that's basically it, and basically the main function, so you're able to run this code. Now let me go and showcase you now the retrieval part, which is basically this part and the final output. So here is the retrieval part. Basically, first point, we initialize the memory because we are utilizing this in the chess-based interface. We initialize the memory, and we are utilizing LangChain framework. That's why we are utilizing here the conversational buffer memory, right? Not the best, it will be improved. Basically, we get the function to get a history from the memory because we're utilizing, because I said this is the smaller part of the whole solution that we're building, and every single one of our agents are utilizing the shared memory state. Then basically here what he does is the function to combine the history and the question. What it basically in short lines, here is the prompt, which is gonna describe the easiest, is here is the previous conversation history, here is the current question. If the user is basically asking a follow-up question, ask it based on the history that you have, and if it's asking the new questions, answer it. Basically this is like a context, right? Because the user might be interacting with some previous requests they had, and it will be related to that. Now the point to the step 2 is the retrieval part, aka function to format documents, right? With the retrieval part, the biggest problem with the LLMs right now in the agentic frameworks is the consistency and reliability, right? That's why we are utilizing here the workflows. So with the retrieval part, we want the formatting be correct, because when I want to see the tweets, and this is going to get improved even more and more and more, but I want to retrieve all the metadata alongside it. I want to retrieve the username, the niche, the client, the date, the tweet ID, the URL. Why? Because the user might potentially ask some related questions alongside it. They want to, let's say, ask, okay, this is the tweet, I got this tweet, but I cannot see their performance metrics, I cannot see the niche they're in, and so on and so forth, right? It gets confusing. In short lines, the format, the retrieved documents, like the pieces of information that we got from the semantic search, from the similarity search, now is basically this, right? We want to have it in this format, right? The tweet, here basically this is the variable, tweet 1, tweet 2, tweet 3, the username, niche, client, the date, ID, URL, and of course the content, right? Now the similarity search, let me showcase you this before I go further. Here is the similarity search, right? This is basically it. Basically, this is the retrieval part, right? The whole part, this is the whole chain, right? But in short lines, this is the retrieval part where it searches for the most relevant pieces of information from the specific documents that we have inside our vector database. In our case, tweets, aka text of the tweets. And currently we have it set around 5, but that's for another one. But in short lines, then once it retrieves, and it retrieves it inside of this format, basically all not just the text, but also the metadata alongside it, returns the result, and then it produces the final response. Okay, we need to make sure the user gets the final response in the nice formatted and readable format, which is basically this prompt that we utilize, the context. Because we're utilizing Streamlit, we also need to tell him what type of formatting and markdowns to use. So it's very nice, right? That's basically it, and that is basically the whole LangChain, right? We combine it with the history and of course the context alongside it. So, and that's basically it. That's the simplest way to put it of building this RAG custom workflow. As I said, this is not an agentic yet, it's just a workflow, aka step-by-step process of retrieving the most relevant pieces of information, formatting them, putting it to the final LLM, the prompt here, the prompt is here, and then putting it back to the user. Now, one thing that I wanted to mention it before I end this video is also this, which is basically called self-query retrieval. This is a function from LangChain which alongside the similarity search, like a semantic search to retrieve the most relevant documents and the pieces of information, what we also get is the LLM interprets the user request, so it's able to provide and filter based on specific metadata fields, right? In our case, as you can see here, one default filter that we have is to provide maximum number of documents, which is 10, because we have a lot of data, and for this video I want to just to minimize it, and whenever it retrieves the documents, it will retrieve maximum 10 most similar documents, and then from those documents and pieces of information it will retrieve, etc., and so forth. You get the point. But the self-query retrieval helps us and interprets the user query, and helps us to narrow down and utilize metadata as specific filters. Let's say in our case, as you can see here, the user might be like, give me the tweets about AI from the specific date, from the ones that are our clients, from the ones that are in the specific niche, and so on and so forth. Basically, this is a LangChain function, which I can showcase you here as well. Let me showcase it here. I'm going to also link down below this, right? Basically, you can go through it step by step, and it will tell you how to implement it. So this is a video of how to build a RAG workflow. If by chance anything that I mentioned to you in this video is relevant and you want to build a custom AI solution, AI agent, you can book a call with our exploration team, and we will provide you with a free data and AI assessment where our team will assess your whole business operation and will provide you with the exact solution, AI solutions, AI agents that you need that align with your top priority business objectives. So if that sounds compelling, you can book a call with our exploration team. Down below, I'm going to also link all the documentation of how to build this step by step, and see you in the next video.